store the data in computer's memory. In a single word, what is data structure? If anyone asks you in a single word or single sentence, data structure is nothing but how we are going to store our data in the computer's memory and how we are going to organize the data. What is meant by organizing here? Organizing means there is some way of storing and there is some way of retrieving the data. Am I clear? So it should be proper way of storing and proper way of accessing the data. Am I clear? So the entire subject of data structure will deals about how we are going to store the data and how we are going to access the data. And of course, there is a different concepts relevant to the data structures. Okay, and we can able to use some of the programming languages like C or C++ or Java, even Java also, in order to implement this data structure subject. Am I clear? So data structure is containing the different ways of storing data, and everything is related to the concepts. And we are using some programming language, let us take C programming language, in order to implement these concepts in a practical way. Am I clear? That is the data structure subject. Basically, it is a theoretical, basically it contains examples, that's it. But as a CSE student, we can able to solve that examples by writing a program. So we are going to use, you can able to use any programming language like C, C++, or even Java also you can able to use. But as it is first year, second semester, up to now as you completed C programming language, we are going to use the C programming concepts or C programming methods to implement these concepts in the data structure. Okay, so that is about the entire data structures, what we are going to be discussing in the data structure. So as the definition of data structure is mainly, as the indicates, data structure. Structure is nothing but a format. There should be a format of storing this data. I mean, we can't able to simply store the data in our own way. If you simply storing the data in your own way, in the sense the accessing the data from the computer will take more time. So what we are going to do in this data structure subject is, we are going to see the different ways or different formats of storing our own data in the computer's memory, and not only storing, and we can able to classify how we are going to access the data from the computer's memory. That is the subject. That is the term data structures. Hope you understand what is the subject now. Okay. And one point of view is that as a university subject is, of course, it is important. Okay, you can able to follow, and it is a basic subject for the different subjects what we are going for. Even Python. For Python also, these concepts you can able to use. Okay, or for Java, or for any other advanced data structure. Any other subjects what we are going to be seeing in other semester, upcoming semester, this is the basic subject. That is the first point. And second point, when coming to the competitive exams like GATE exam or for any MNC interview questions, the data structure should have the minimum weightage. Because here we are not going to discuss the programming concepts. Here we are going to be discuss the methods of efficient data structures. We have different data structures now. We have stacks, queues, linked list. There are different data structures we have. Okay, each and every data structure we need to be examined. Okay, what are the operations we have in the data structure? Okay, and what is the time taken to access the data in that particular data structure? Okay, so this type of methodology we need to be followed for every data structure. Data structure, there are different types of data structures we have. Some are saying that linear data structure, non-linear data structure. Again, linear is classified as stack, queues. Again, non-linear is being classified like trees, graphs. There's different types of data structures. Okay, for every data structure, we need to analyze how the data structure will work. Means how the data is being stored, how we are going to access the data, what are the operations we have to be implement onto the respective data structure. So these things we have to be performed for every data structure. That is nothing but our entire data structure service. For every data structure, we need to be comparable. For example, let us take a simple stack and queue. These are the two names for the data structure, two different data structures. we need to analyze what is stack, how the stack is being implemented, what are the operations of the stack. Completed. Stack is completed. Then go for the second one, queue. What is queue? How the queue's data structure is being implemented? What are the operations in the queue's data structure? Yes, queues is completed. Then what we have to do is we have to compare the stack and queue. Which one is the best one? In general, in computers, which data structure is being used? In which situation, which data structure is being appropriate? Okay, all these we have to be learned in the entire data structure syllabus. Am I clear? Very easy and no need to by heart now. Okay, you need to remember easily. You need to understand the concepts very well easily. No problem. Okay, so let me start what the syllabus we have in the unit 1. As the other faculty like Swati ma'am already discussed, maybe discussed this syllabus. So let me give overview what we have in the unit 1. Then I will go for what is the definition of data structure, and we will start discussing about the unit 1 syllabus. Okay, so when you are going for the unit 1 syllabus, the unit 1 syllabus is the very basic thing they framed now. Okay, in the unit 1, initially they included what is the meant by data structure, or what is the definition of data structure, and what is the classification. Classification indicates what are the different data structures we need to be discussed in the entire syllabus, entire 4 or 5, 6, 5 units of syllabus. Classification. Okay, then what are the operations? Okay, here the operations on the data structures means one data structure operation may be different from another data structure operation. The names may be different. And here the operations is nothing but inserting data, deleting the data, or modifying the existing data, or sorting of the data, or merging of 2 or 3 data sets. Okay, all those will come under the operations on data structure. We consider one data structure. Let us take stack. How to implement this stack data structure? What is the format of stack data structure? Why it is called as a stack? Okay, and what are the operations? For example, operations on stack data structure means push, pop, is empty, is full. Example I am saying. I will explain. Okay, these are the 4 operations we have on the stack data structure. We need to be discussed what is meant by the first operation like push, what is meant by the second operation pop, what it is, what it will be performed, and third one what is empty, is full. What is all these operations? Okay, theoretically we have to be discussed first. Then we are going for some example how the elements or how the data is being stored in the stack and how these operations is being implemented. So we need to be discuss the examples also. Then we will go for the programming. Means whatever the operations we need to be performed on the different data structures, we need to write the code, programming code. Means we are going to use the C language in order to write the code for these operations. Am I clear? Next one, what is abstract data type? Okay, you already aware what is meant by data type. In the C programming, you already know what data types are nothing but integer, float, char, string, okay, list, tuple, okay, all these are data structure. But you should know, aware what is meant by this abstract data type. Okay, we will discuss in this session only. Okay, then preliminaries of algorithm, what is meant by algorithm. Okay, in order to write the algorithm, what is the requirements we need to be identified. Okay, then we will go for time and space complexity. Very important concept. Okay, how much of time it will take to access data onto a stack data structure, or how much of space is required, okay, in order to make some operation on stack data structure. Example, I am taking stack. For all the data structures, we need to identify how much of time is required and how much of space is required to perform the operations of data structure. Okay? So that is nothing but time as well as space complexity. Okay, this is half of the first unit. We need to be discussed. No problem. We will need to be discussed every point or every word what we have in the syllabus. Okay. Next, searching. Okay, as you already know that searching is one of the operation. Okay, so there's the different methods we have in the search, like linear search, binary search, Fibonacci search, the different methods. All these three methods are meant for searching of a particular data element onto the memory. But why you have the three different types means linear search will take some time, some amount of time to perform searching. Binary search may take minimum amount of time in order to search any element on the data structure. Similarly, Fibonacci, it takes its own time, it takes its own space. Okay, comparatively, we have to be learned. And comparatively, we have to decide which type of searching technique or searching operation is the best one. Okay, in exam point of view, everyone is important. Okay, everyone has their own weightage. Okay, they may ask what is linear search, what is binary search. They may ask you to write example. But comparatively, you have to learn. In that level, you have to be learned. Okay, so that is about different searchings we have. And of course, we have sorting. Sorting is also one type of operation. We need to be performed on the data what we are stored in the memory. Okay, again, sorting, there's a different type of sortings. Insertion, selection, bubble sort, quick sort, radix sort, merge sort. Okay, each one have their own priority. Each one have their own time complexity. Each one have their own space complexity. Okay. According to the situation, according to the perspective of the user, okay, we can able to go for quick sort, we can able to go for merge sort. Okay, sometimes in semester exam they may ask you which type of sorting is the best one. How? Explain with an example. These type of questions also you may get. At that time, you should aware comparatively, you should aware each and every concept, and comparatively you should aware which one is the best one. I will explain, sir, how we are going to decide which one is the best one. On what basis we have to decide which sorting technique is best. That we will discuss. The end of the unit, you should be in a situation that comparatively you have to be learned. Every concept comparatively you have to be learned with every other concept, so that you will get the clear idea. Not simply by heart the examples of how the insertion sort will be done. Okay, how the bubble sort will be done. Don't simply by heart the examples. Starting in the class, I am saying this because in the exam situation, in the exam paper or any interview or MNC interview questions or anywhere, they will not give the same set of examples. Okay, you should completely aware the concept, how you are going to sort the given numbers, or how you are going to sort the given data. In the quick sort, what is the method they are following? Okay, in the quick sort, what is the time complexity or time taken to sort the elements? Okay, it required in the quick sort. Merge sort, what is its method? Okay, the time complexity of every sorting technique is different now. Most probably different. Okay, merge sort is the best one because it requires very less amount of time to sort the given values. Am I clear? But that you should not be by heart. Okay, you should aware the concept. You should take your own numbers or you should take your own data, then go for sorting. Am I clear? You should follow the method, then it should be completely aware from you. Am I clear? So that is about the syllabus now. So let's start with what is data structure and what are the different data structures we have. Okay. Is everything is clear, ma'am? Is any problem with my voice or something?
No, sir.
At any point of time, any problem is there, please raise your voice, anyone or Kirtana, anyone, so that I can, because I am in the presentation mode, I can't able to see the messages here. Okay. So here we have the different points about the data structure definition, what we have in the data structure and everything. But simply you should remember what is when the data structure, as the name indicates, the way of storing data and way of retrieving the data or accessing the data from the computer memory is nothing but data structure. You can able to use this sentence for the definition. You can able to write anyway. Data structure is the way of storing and organizing or accessing the data onto the computer's memory. Simple definition. Of course, as you are going to refer the textbook, you may get some points from the textbook. Okay, no problem. You can able to get the points also. But basically, no, don't go for by hearting the textbook. Simply understand the points what the definition is saying. Okay, so the data structure is a way of storing, okay, and way of organizing. And not only storing and organizing, we are going to access. How we are going to access the data is also set by the definition of data structure. Okay, hope you remember this simple sentence. That's why I given this sentence. Okay, now come to the definition what they given. Data structure is a specialized format for organizing and storing data. Simple, most probably same. What we are going to do is there should be a specific format of storing our data. Am I clear? And organizing. Organizing means appropriate way of arranging. That is the first thing. Then go for accessing the data from the appropriate data structure. Simple example. As already I hope already you were aware about arrays. The array is also a data structure. Why array is a data structure? Array is the definition of array itself is saying that array is a homogeneous data structure. What is going to be homogeneous here? The data values what we are going to store in an array, it should be of same data type. Either you can able to take integers, every data value what you are taking, it should be of an integer only. Am I clear? For example, if you take a characters, every value it should be a character. For example, if you want to store the strings, all the values what you are storing in an array, it should be of homogeneous. Means same type of data should be stored. Am I clear? First point. Second point, how we are going to access the data from the array? Based on the index. Storing is also based on the index. Accessing is also based on the index. Means the index value of an array starts from 0 to n minus 1. Okay. Index location at 0, index location at 1, 2, 3, and so on, n minus 1. Okay. We are saying that size of an array is n. Okay. So array is also one data structure. The way of storing data is in a continuous manner. Am I clear? And what is the type of data you are storing in array? Homogeneous. And how you are going to access the elements from the array? Based on the index. These 3 points you remember. Not only array, for any data structure. Again, I am repeating now. I am saying that array is a data structure. Okay. Okay. How we are going to store the data elements? In a continuous manner. Continuous manner in the sense, starts from index 0, index 1, index 2, and so on up to n minus 1. First one. How we are going to store the data. Then, how we are going to access the data? Again, based on the index location. If you are given array name is CSCB, this is the name of an array. I can able to write here. If you consider the array name is like CSCB, then how you are going to store the element? How you are going to access the element? As it is an array, you can able to consider ECB of 2. What this indicates? Onto an array at an index location 2, we are accessing. That is the way. Am I clear? Means the way of storing and way of accessing is also based upon the index location. Am I clear? And what is the type of data stored in array data structure? Homogeneous. Means in one index location, we are inserting integer. At index location 1, we are inserting integer. At index location 2, you are not allowed to store string. Again, at some index location, you are not allowed to store characters. Means every index location should contain the same type of data. Means homogeneous. So array is one of the basic data structure. Start from array, we have stack, queues, linked list, trees, graphs, different type of data structure. So for every data structure, these 3 points you have to remember. How we are going to store the data, how we are going to access the data, and what are the operations that particular data structure will have. That is about data structures. So that is the first point here they mentioned. Data structure is a specialized format for organizing and storing of data. Next, a data structure is a collection of data elements or data values. The relationship among them and the functions or operations that can be applied onto the data. Am I clear? You are not simply storing the values. They may have relation from one data value to the second data value. They may be. Okay, for every data structure, the data values what it have may not have relationship now. Am I clear? They may have relationship. Am I clear? For example, let us take an array. Index 0 to n-1. You store like your roll numbers. Roll number 565, 566 and so on. What is the relation? Relation is nothing but continuous roll numbers. Am I clear? That relation may not be have for every data structure or for every data values. Am I clear? And next one. Functions are the operations that can be applied onto the data. Am I clear? What is the operations? What is meant by function? Means accessing, inserting. Already data structure is created. I am going to insert some elements. Inserting is one operation. Okay, I want to delete so and so element in so and so index location. Delete is one operation. Am I clear? I want to sort the values. Basically, data structure is there. It has some values. I need to sort them in an ascending order or descending order. Then sorting is one operation. Am I clear? So all the operations or functions that can be applied on the data is also be considered in the definition of data structure. Okay. These points you have to be note down now. Okay, or if you have textbook, you can able to open, you can able to underline these points. Okay, because in the exam point of view, they ask the definitions. So first of all, you have to write these points, then you can able to write your own explanation. Okay, so go for the third one. Data structure can be used to organize the storage and retrieval of information stored in both main memory and secondary memory. So till now, the definition of data structure says that the way of storing, the way of accessing, nothing but retrieval of information. But from where? Where we are storing this data? From where we are going to accessing the data? Is nothing but main memory or secondary memory. Hope you already know what is main memory and what is secondary memory. Am I clear? RAM, random access memory, ROM, okay, and pin drives, USB, CDs, all those comes under the main memory as well as secondary memory. USBs, CDs, DVDs, okay, external hard disk, all those comes under the secondary memory. Okay, RAM, okay, internal hard disk space, all those will comes under the main memory. Means wherever the data we have, either it may be a main memory storage location or it may be a secondary memory location. Our aim is we are going for efficient storage of data. Okay, efficient. Sir, why you are using the word efficient? I will explain. Efficient way of storing data and efficient retrieval of data from the computer's memory is required. Am I clear? Now come to the point. Why you are using efficient? As already discussed. Efficiency is based upon how much of time it will take to access the data, or how much of time it will take to store the data, or how much of time it will take to perform any other operations onto the data with respect to the data structure. Am I clear? Basically, we will start with array. Array have one problem. What is that? Array will not support the heterogeneous collection of data. Am I clear? Am I clear? Then go for stack. Stack is one more data structure where it can able to allows the different data types, different values, it can able to store. Then go for queue. Stack has one problem. Then we are going for queue. Okay, queue we are saying that it is inefficient because comparatively before that stack, comparatively before that array, queue is most efficient. Am I clear? Then go for after queue we have linked list. It is most efficient because wherever the computer memory free, it can able to store the data. Am I clear? Means every data structure can have their own advantages and disadvantages. Am I clear? We can able to say every data structure is efficient, but how much of time taken to perform some operation, based on that we can decide which data structure is the efficient. Am I clear now? So go for the last one. There are numerous types of data structure generally built upon simpler primitive data types. Okay, you should know what is meant by this primitive data type. In C programming, you already know what is meant by primitive data types. Primitive means integer, float, char, string. Am I clear? Other than non-primitive data types, we have unions, structures. Okay, those are non-primitive data types. Means all those different data structures, what we are going to be discussed, they are generally performed on primitive data types. Means our data should be stored maybe are different data types, which are integers, maybe float, maybe char, maybe strings. Am I clear? So this is about the definition of data structure. Okay. First and second 2 points are most important. These two are most appropriate for the definition of data structure. Okay. Second point is most important one because it is very clear definition. Data structure is a collection of data values, the relationship among them, and the operations or functions. Okay. Operations means we are going to consider inserting, deleting, sorting, searching, traversing, merging, all those comes under the operations. When you defining these operations as a function, means you already know what is going to be the definition of function. We are going to write swap is one function. Within the swap function, you can able to write some set of statements. Similarly, in order to perform the insert operation, we have some set of statements. Those are all being grouped together as a function. Okay. For example, if you want to perform searching, okay, searching is also can be defined as one function because in order to perform search, we have to write some set of statements in the program. So we are considering that as a function. Every operation what you are going to be performed on the data of a data structure should be considered as a function in the programming side. Theoretically, we are calling them as a function operations. Okay, but practically at the time you are writing program, okay, we have to write individual functions. For inserting, we have to write one function. For deleting, one function. Sorting, one function. Searching, one function. Merging, one function. Am I clear? So that in the definition, that's why I highlighted the points now, important keywords. Collection of data values and the relationship between among them, and what are the operations or the functions that can be applied onto that data. Hope you understand now what is meant by data structure, at least. Am I clear? If you understand what is meant by data structure now, then go for classification of data structure. Okay, very important diagram. No need to by heart it. Okay, many times they will ask you in many objective types questions or any 2 or 3 marks question, list out some nonlinear data structures. Example, explain with an example. List out some non-linear data structure. Okay, explain so and so data structure, so and so linear data structure with example. They may ask these type of questions. Am I clear? So till now we discussed what is meant by data structure. Now data structure is classified into linear data structure, non-linear data structure. Here, what is meant by this linear and non-linear? If you understand this term linear and non-linear, okay, then 50% you should understand the difference between these 4 data structures with these 2 non-linear data structures. The basic difference you will understand. Okay, so let me focus on what is meant by this linear. It is not a complicated word, no? It is just like an English word. Linear in the sense a continuous, okay, a sequential, the way of accessing or storing, whatever it may be. The data structure is mainly focusing on linear, sequential, continuous, means our data values, whatever we have, okay, those are located in the computer's memory in a sequential manner. Okay, you should have a why you are including array here in the linear data structure. See, the relation array is given in the linear data structure. Linear data structure is one of data structure. Why you are including array in the linear data structure? Why not we are including array in the non-linear data structure? Because the structure or the format given for the array, it should be in a continuous manner. The data, it should be in a continuous, index 0, index 1, index 2, and so on. That's it. Okay. Our data value is stored in index 0. Second data value is stored somewhere in the index of 100. Third data value is stored somewhere in the 1000 index value. No, that is not linear data structure. Am I clear? So the term linear in the sense the data is being organized or stored in a continuous or sequential storage. Am I clear? Am I clear? So what is the constraint to implement this linear data structure? Again, I'm repeating my question. What is the constraint? Means what is the condition need to be followed while you are implementing linear data structure? Answer is, in order to implement array or in order to implement stack, queues, linked list. Okay, linked list, we will discuss about linked list now, because linked list will act both linear and non-linear. That is another way. So either it may be array, stack, or queue. If you want to implement those data structure, the first constraint is we should require a memory. It should be in a continuous manner. Otherwise, you cannot implement. Simple example. I have some 10 data elements. I need to store them in the computer's memory by following the array data structure. Am I clear? I have 10 elements, 10 data elements. Maybe your roll numbers, maybe your names, or any type of data. I have 10 data values. I need to store them in a computer's memory, and I am following array. Okay, if you are following array as it is a linear data structure, what is the constraint? I should have 10 memory locations. Those should be in a continuous manner. Otherwise, I can't store my 10 elements, because array is a data structure which is of type linear. Means array will be implemented only when we have a continuous memory storage. Otherwise, array will not be used. Like for example, 10 data elements I have. I require 10 memory locations for an array so that I can store them. For example, operating system allows the array whose size is only 5. Means I created an array whose name is CSCB. Okay, it contains the size of only 5, 0 to 4 index values. I can't store my 10 values onto memory location by using array. Am I clear? Hope you understand. Hope you are following my class, ma. See, for example, I have an array. Okay, starts from index 0, index 1, 2, 3, 4. 1, 2, 3, 4. Means the size of this particular array, let us take name A. The size of this array is only 5. For example, I have 10 data elements. 10 data elements. What is the type of data, sir? Any type of data. I have 10 data elements. Can I be able to use this array? No. Why? Because for the first 5 elements I can store. What about the remaining 5? I can't store them. Am I clear? Means this particular array A is not accommodate for my 10 data elements. Am I clear? Hence, this array is not sufficient for me to store the data. Am I clear? For example, if the array size is like 0, 1, 2, 3, 4 size and up to 9, or let us take up to 10, means whose size of an array is greater than my requirement, then I can able to use array, because continuous memory locations are available for me so that I can store my data. I can able to perform any operation by using that array. Am I clear? Am I clear? So that is meant by linear data structure. Am I clear? So array is one of the linear data structure. Similarly, stack, queue is also one type of linear data structure. Means at the time you are implementing these data structures, okay, you should definitely contain a memory locations which are in a continuous or a sequential manner. Am I clear? Okay, now come to what is meant by non-linear. Contrast. What is meant by non-linear? Non-linear in the sense, my memory requirement is 10. These non-linear data structures, they allocate the memory. First 4 memory locations are somewhere. Next 4 memory locations are some other way. Remaining 2 memory locations are somewhere in the entire computer's memory, in order to accommodate my 10 data values. Am I clear? So that is meant by non-linear data structure. Am I clear? Memory is allocated both in the linear data structure and non-linear data structure. But in the linear data structure, for my 10 data elements, all the locations should be in a continuous manner. For my non-linear data structure, it is also accommodate my 10 memory locations. But the 10 memory locations may not be in a continuous way. Wherever in the computer's memory we have free. Already in the current semester you may have computer organization. In the computer organization you should aware how the memory is being allocated. Okay, so anyhow, in the nonlinear data structure, memory is being allocated for your data based on the user request, but the memory locations are not in a continuous manner. Okay, so that is the difference between linear and non-linear data structure. Okay, linear in the sense array, stacks, queues. Non-linear in the sense graphs and trees. Now come to that most tricky data structure is about, one second, is about linked list. Here, linked list will act both linear and non-linear. Means at the time of allocating memory locations, it is considered as a linear. Sorry, at the time of allocating memory for storing the data, it will act as a non-linear. Okay, but at the time of accessing the data from the computer memory, it will act as a linear. Okay, I will draw a small figure here now. How the linear data structure linked list will be implemented. For example, this is the entire computer's memory. For example, a small example. Memory locations. Let us take these are all memory locations. Okay, and these cross marks are considered as already filled with data. Randomly, I am filling now. Okay, so this is our entire computer's memory. Okay, and all these cross marks what are included here, those are filled with some data. Already it's filled with some data. Okay, so now we are going. We are having 10 data elements. We need to store in the memory. Okay, of course, linear data structure is not appropriate for this situation because ekkada kuda chudandi ekkada kuda 10 memory location continuous ga levu. Okay, so obviously linear data structure either stack or queue or array will not appropriate. Obviously we'll go for either non-linear data structures like graphs or tree or linked list. What this linked list will do is for your 10 memory data for your 10 data values, it will arrange 1, 2, 3, 4 locations, 4 memory locations for your first 4 data values. Then for the 5, 6, 7, 8, 9, wherever free memory location is there, fill it. 9. For the 10th one, it go for some other location. So the linked list will assign memory randomly wherever it have free space. Wherever you have the free space. Means at the time you are storing the data, it will consider as non-linear. Am I clear? But at the time you are accessing the data, am I clear? What the linear linked list will do is memory. See here. Memory location 1 will have a link to memory location 2. Memory location 2 will have a link to memory location 3. 3 will have a link to memory location 4. Memory location 4 will have a link from there to memory location 5. 5 to 6, 6 to 7, 7 to 8, 8 to 9. Again from 9 to 10. Linking are there just like your pointers. Just like your pointers, every memory location will have a linking to every other next memory location, so that all those 10 memory locations what I allocated for 10 data values, those have linking. Means at the time of accessing, those are considered as a linear data structure. Hope you understand. For example, let us take you have a cinema theater, movie theater. Okay, you have 10 students. You went for a movie. Okay, 10 entire row you will not book it. Am I clear? Randomly you have seats 4 in one row, 4 in some other way, another row, 2 in some other row. Am I clear? You are scattered among the places. 4 students you sit at one place. Of remaining 4 students you seated in one row. 2 students seated in some other row. Okay, randomly distributed means non-linear. Am I clear? But every student is aware of every other student. Am I clear? For example, I need to know the 10th student. I need to meet with 10th student. I can able to access from roll number 1, 2, 3, 4, 5, 6, 7, 8, 9. Then I can go for 10th student. Not only 10, for every student. In order to access any student, okay, every student have a contact of every other student. So that at the time I am going to accessing any student, I should be in a linear way. Hope you get the example. Okay, so this linked list will act both linear and non-linear. At the time of storing the data, it will act as a non-linear. At the time of accessing the data, okay, it may feels that it is a linear data structure. Okay, so here every data structure is one unit now. Okay, in our syllabus, maybe array is not be considered as a unit. Stack is maybe one unit. Queues, linked list, graphs and trees is one unit. Am I clear? So stacks, queues, linked list, linear data structures. Okay, graphs and trees, non-linear data structure. Okay, sometimes linked list you can able to consider for both linear as well as the non-linear data structure. Am I clear? So this is the introduction about what is data structure, how the data structures is being classified. Okay, so we'll continue what are the operations we have in the data structures. Okay, how these operations will be performed. Okay, in the next class. Okay, anyone have any doubts up to here? Anyone?
No, sir.
I hope this is the introduction given for the session, ma. So quickly give your attendance, ma. I will call the roll numbers. Please raise your voice. Okay, then I can able to note the absentees. 65.
Present, sir.
66.
Present, sir.
8. 67. 67 Kartikeya is not there. 68.
Present, sir.
9. 69.
Present, sir.
70. 71. 71. Or else you can take a message. మీరు మెసేజ్ అని పెట్టచ్చండి. మీరు మెసేజ్ పెట్టినా నేను నెంబర్స్ చూసుకుంటాను ఇంకా. Or else you can able to raise your voice. 72, 73, 74,
Present, sir.
75, 6,
Present, sir.
77,
Present, sir.
8,
Present, sir.
78, 79, 80, 79, Jahnavi is not responding. 80, 80 also not responding. 81, 75, okay. 81, 81,
Present, sir.
82,
Present, sir.
83,
Present,
84, 85,
Present, sir.
87, 88, 89, 89 not there, 90 not there, 91,
Present, sir.
92, 93,
Present, sir.
92 is 92, 93,
Present, sir.
94,
Present, sir.
95, 96,
Present, sir.
97, 97, 97, 98, 99, 98 is not responding. A1, A2, A0 is not responding. A3, A3, A4, A5, A5, A6, A7,
Present, sir.
A6 is not responded. A8, A8, A9,
Present, sir.
A8 is not responded. B0,
Present, sir.
B2, B3, B4,
Present, sir.
B5,
Present, sir.
B7, B8,
Present, sir. B8 9.
B9, okay. C0? C0. Bhavya, C1, C0 is not responded. C1, C2, C0, okay. C2, okay. C3,
Present, sir.
C4, C5, C6,
Present, sir.
C7, C7, C7 is not responding.